Hello everyone, welcome to Filmstorm.source code, and I'm Kieran, and today we're going to have a look at creating something really exciting, and it's probably one of the biggest issues to solve in a game, and it's your decision on a camera. And we're going to look at how to create a third-person camera, all in C# inside Unity, so you don't need any other plugins. This is going to be completely standalone. I'm going to give you everything that you see as we create it, so you'll get the finished project files to have a play around with. So that'll be really exciting. And what we're going to do is we're actually going to focus on a camera that intersects with walls, which is going to be really exciting, and it's pretty simple to set up. So if you come to your models folder that you'll see when you download it, we've got our mannequin. So let's just let's just zero him out. And you'll see that we have an animator. And just for the time being, just so we have some reference, let's just create a movement controller. And let's just pop that onto the mannequin. And then that way we can come into the animator, come back to the assets, and let's just drag in our idle animation. And if you click play, you'll see that he's chilling in the scene and he's doing a nice little idle. So now we need to start working on our camera. So let's just bring this guy in here. Let's just leave him around there. Let's create a new empty object and rename it camera base. So this is going to be our camera base, and let's make it a height of 1.35, something around there. And let's just drag our camera under the camera base, and we'll just zero it out just so it's all centered, and then we can just drag it back. And we'll just leave it around there for the time being. So you can see if you go to the game view, you click play, we're gonna have this camera, but we want to be able to move our mouse around and have the camera move around the character. So let's come and just drag that down. Let's create a new folder and call this scripts. And this is where we want to keep all our scripts to keep it nice and tidy. Let's create a new C# script, and we're going to call this one camera follow. These bits and pieces, and basically when we create a new script, it's going to create a class, and it's going to name that class whatever we named the file. So it's going to call it camera follow in our case. Now what you want to do is just enter down a few times, and we need to put all our variables in. So if you're used to Playmaker, you know that the variables tab on the end, this is where we would set all this up, and it's pretty simple once you get used to it. And so for now, let's create a public float, and we want to say camera move speed, because this is going to be how fast our camera moves. And what you want to do, whenever you have a float, which is basically a number with numbers after a dot point, or you can have an integer, which is a full number, like a whole number that doesn't have any integers. That doesn't have any remainders or anything after. It's like a full whole number that can't have any more remaining points. So what you want to do, whenever you have a float, it's always good just to put that little f after your number, and in that way it's always going to compile correctly for you. So let's just say our default move speed is going to be 120. Let's create a public game object. So this is the same as saying new game object, and you want to say camera follow object, and this is going to be what our camera follows. So just to show you right now, if we save it, minimize this, come back to our game, come to the camera base, and drag our camera follow onto the camera base, you'll see that we already have all these variables popping up. And because we made them public, that means we can see the variables from like the editor's side, so we can actually edit them on the front end. If you didn't want people to actually see these variables, what you can do is then just either make it a private. So if we make that camera move speed private, save it, come back, compiles, and you'll see it disappeared. So that's pretty cool. So let's just make that public because we want to be able to change that in the future if we want to slow down the camera or do something. Okay, so now let's create a vector 3 and we want to say, call this the follow position. We also want to create another public float, and this is the clamp angle, which is basically how high or how low we want to be able to look. We want to create another public float, and this is the input sensitivity. There we are. And this is how sensitive our controller is going to be. Public game object, and this is going to be the camera object, which is going to basically the this is just going to be the camera public game object, and we also want to get the player object, and then we want some more public floats, and this is going to be cam distance x to player. And you can basically copy this line because we need to make this on each axis. And we want to change the x to y and the x to z. So you have x, y, and z. A couple more things. We just need public float mouse x, which is the horizontal of the mouse, and public float mouse y, public float final input x, and I'll show you what we're going to use this for, and final input z. Good, and we just need two more public, or actually four more. We need public float smooth x and public float smooth y, and then just get some private floats in there, private rotation y, and we'll initialize that to 0, private float rotation x, and that is also equal to 0. So now that we have all our variables sorted, you'll notice that we have this little start thing, and this is basically whenever the game loads for the first time, it's going to run this method. And you can set up all different kinds of things. You can basically call references, get game objects, do everything that you only want to do once at the start of the game. So what we want to do is, let's just jump into here, and we want to say, we want to create a new vector 3 and call it rot for rotation. And we want to say transform, which is going to be this transform of this object. Get the local rotation, which is basically its rotation in the self space. And we want to get the Euler angles and pop that on the end. We want to say that variable that we just made. So this variable here, rotation y, is equal to that rot.y. And rotation x is equal to rot.x. So basically we're getting the rot in vector 3, we're getting its Euler angles, and then we're setting those Euler angles to the dot y to get the y variable, and the dot x to get this x. So it's basically going to replace this, chuck that in there, and it's going to do that calculation for us. Now another thing I like to do is when I'm working on cameras, I like to block the cursor. So you can type in cursor dot lock state equals cursor lock mode dot locked, and that's going to lock the cursor so you can't move it around. And since that's going to lock it in the middle of the screen, we can say visible is false because we don't want to see it anymore. So that's basically, we've initialized it, we're getting the variables, we've locked that all together. So now we just need to set up the rotation of the sticks here, because this is also going to support the controller. So firstly, we need to jump back to Unity, and inside Unity, and you'll just notice that we've all those variables popped up there. We need to come up to Edit, Project Settings, Input, open up axes, and let's make it 19. You notice a new cancel appeared here. And we want to call this right stick horizontal. Get rid of all this, make it 0. I usually just change those to those variables. And fourth axis is actually the left axis on the control stick. And then if you click and make this 20, it copies and pastes that, so you don't have to spend time doing that again. And then call this next one vertical and make that number 5 because it's vertical on the stick. Alrighty, so now that we've got that set up, we can come back to our update. And we want to start to get some of the sticks. So we want to create a new float, and we want to call this input X. And we want to get the input get axis, which is pretty much the same as Playmaker if you're used to that. So we're getting the axis, and we want to say what axis we want to get. And we want to get the right stick horizontal. And you want to make sure you spell that absolutely right, exactly the way you have it. Otherwise, it's not going to work. Now we want to get the input Z. So we want to get that vertical stick. So you want to say get that, and we want to say the right stick vertical. Excellent. Now we want to say mouse X is equal to input dot get axis, and we're going to call this mouse X because that's what it is in Unity. And we want to get the mouse Y and input dot get axis. Whoop. And we want to get mouse Y. Yep, that's right. And now, how are we gonna merge these two together is go get that final input X that we made up the top, and we want to get input X plus mouse X. So basically, depending on whichever one you're using, we're just gonna get that. And then final input Z is gonna be equal to input Z plus mouse Y. So that's pretty cool. So basically this final input is going to give us either the mouse or the controller. Now we want to say that rotation Y that we made up here is going to be plus or equal to final input X times our input sensitivity times time dot delta time. Alrighty, so that's basically gonna rotate the stick depending on which way we're pushing. And we want to do the same for rotation X, is plus or equal to final input Z times the same input sensitivity times another time dot delta time. And now rotation X is equal to mathf.clamp. So basically we're going to clamp that value so it can't go higher or lower. So that basically, that's going to stop it from going around and around in circles. We want to clamp rotation X to a negative clamp angle and to a positive clamp angle. And then we want to get a quaternion and get the local, call it local rotation, and that's going to be equal to quaternion dot Euler at rotation X, rotation Y, and 0 and semicolon, and then transform dot rotation is equal to the local rotation. Excellent. So that's basically the update. So it's going to rotate it. Now we want to just create a void late update. So basically this happens whenever, I think it's after a frame or something, it's that's when it gets called. And all we want to do for this one is call a new method, and we're going to call this camera updater, updater. And we haven't created this method yet, so let's create a new method, call it void camera updater, the same as what we just made. And you'll see that that turns from red to normal. Excellent. And then all we want to say is transform target is equal to camera follow object dot transform, and then we want to move towards the game object that is the target. So basically, here we set the target object to follow, and then we move towards that. So how are we going to do that? We're going to go float step is equal to camera move speed times time dot delta time, and then we're going to get transform dot position, which is this object position, and we're going to go vector3 dot move towards and transform dot position target dot position and step. Excellent. So now if we save that, go back to Unity, jump on that camera base, you'll see that we have all these objects now. What we need to do is we need to create something to follow. So let's create a new empty object inside our player and call this camera follow. And it's handy to create this because that way you can offset it to the height you want. So you create 1.35, which is what we set that camera base, and then drag that camera follow into your follow object. And if we say play, you'll see that the camera is fully working. And if you can hit escape and you can still move your mouse if you need to get out of it. So if I bring the camera down, I'm gonna have to also invert the input. And if I move this forward, you see the camera's moving, and that's moving through the script. So that's pretty cool. So one thing we want to do quickly is just go input and then come to mouse Y, and I just want to invert that because that will give you a nicer mouse feel. And you'll notice the clamp. So if I push down to 80, that's gonna stop the mouse. And if you don't want it to go as far as that, you can go back to here and then make the clamp angle like 66. And if you want a different clamp angle to what you so if you want the height to look higher and you want the feet to maybe stop like here, you can always come back to the script in your clamp angle and then make a separate clamp angle for your minimum and your height. But for now, I'm pretty happy with that, so let's leave that. Now for the next thing, say you had an object like in most games, and say we put it on the side here, and if I come here, now if I had the camera and I pushed it, see how we kind of intersect it? We want the camera to be able to dynamically move in front of this object. So how are we going to do that? Well, we need to actually create a new script, and this is actually really simple, and we want to call this camera collision, and this is going to handle all our collisions. And for this script, we want to pop that on the camera, and let's open this guy up. Alrighty, so now again we need to create some variables. So let's create public float min distance. So this is going to be the minimum distance the camera can go, and we can always customize this, and because we're making it a public variable, we want to make the maximum distance. So let's make that around 4. We want to create a public float, and we want to get a smooth and make that 10. Let's create a vector 3, and we want to create a dolly direction. We want to create a public vector 3, and we want to call this the dolly direction adjusted. And we want to create one more, and we want to create a public float distance. Excellent. Now, in this case, we don't need a start. We just want to make one that's called awake, because as soon as this is awake, we want to adjust some variables. So we want to call the dolly direction first, and we just want to set that to transforms local position. So this is the camera's local position, and we want to get the normalized variable. And we want to set the distance to transform dot local position dot magnitude. So the magnitude. And once you see how easy this script is, you're going to be kicking yourself. So let's go and make a vector3. And we want to call this vector3 the desired camera position. And we want to call this transform.parent.transform_point. And that transform point is going to be the dolly direction times the max distance. Now we want to do a quick raycast, so let's call raycast hit, make a hit, and then we want to do an if statement. So we want to say if physics.linecast is the transform.parent.position, and the desired camera position is gonna send us that out hit, then, whoop, we don't want to do a coroutine. So if that is true, we want to say the distance is equal to math.clamp. So we're using this clamp again. We're going to call the hit.distance is times by 0.9. Now this is a really cool little trick because we're getting that distance that we're hitting the wall, right? And just for now, let me just get rid of that and I'll show you what's going to happen if you don't have that. So let's just put a comma there for the time being. So min distance, max distance, and then we want to say, we want to call this else the distance is equal to max distance. And then we just want to finish off this, so you can see this bracket is here, and we want to say then transform.local position is equal to vector3.lerp. We want to lerp it, and we want to say transform.local position dolly transform times the distance, and then get a time.delta time, and we want to smooth that out. Very exciting. Okay, so now, actually we want to probably get rid of that bracket because I was going to show you about that. So we're going to come back to this because this is what's going to make it look really nice. So if I save that, come back to your main camera, you can see we've got all these variables. If I hit play, it's going to adjust it, and if I push forward, we've created that thing. But you'll notice to start off with, if you, let me just make the game view bigger. Most commonly what happens is when you come down, you'll see that you can see through the floor, and people will be like, oh, okay, well, why don't I just change the clipping plane? Well, I would only push the clipping plane to about 0.1, because if you make it 0.01, you're going to actually lose out on your shadow quality because it's basically rendering so much more information. You wouldn't think so, but it actually is. So bring it down to 0.1, you'll notice there's a little bit better, but you're still looking through the floor. So how are we going to fix this? Well, what we can do is let's come back to the script. Let's whack that bracket back in there. Let's times it by 0.9. So basically we're going to reduce that distance, or we're going to times it by about 90%. So that hit distance is getting times by 90%. So now if we hit play, you'll notice that it doesn't clip through the floor. And if you don't want it like you don't want to see through the floor as much, you can even reduce it even more. You can bring it to about 0.887. And I mean, for a simple script, this is probably pretty good because, I mean, you're going to still have to go through the floor first for it to actually register. So what we can do is you have to do another line cast, like pretty much down, and then you'll be able to avoid that initial clip. Or, I mean, you could always do the old hardcore method of just doing that, and that will kind of reduce it. But for now, I mean, that's a pretty good script that has full camera collision all working, and it reacts pretty quickly. And if you want this min distance, so you can say min distance is like 0.2. You can have the max distance at like maybe 2.9. You can make the smooth like 5. So that looks even better right now. There you go. So now it's not clipping through the floor before we go through, just with that little simple change. And there you go. So basically we have just created a full camera system. If I use the right stick, you can see that it's doing it. So right now I'm using the stick, and you see we clamp really nicely, and we also clamp above, we clamp, and when we push back, we're still colliding with all the stuff really nicely. And that is a very nice simple camera system set up, I'm not sure, under half an hour. So thanks everyone for watching, and thanks for tuning into the first episode of Filmstorm.sourcecode. I'm really happy that I finally done enough research to learn C#, and I hope to see you all in the future tutorials. Thanks everyone.